Hi everyone. Happy Wednesday. So this is our last class together. I assume that I will find out soon when your final exam is going to be. I'll email the department, but I haven't heard yet. So we don't know the exact date for the exam. I'll send an email out as soon as I know. Unless have you guys heard anything about that? Like, do you guys have dates for any of your other finals? Okay, yeah, that's very slow moving, but oh yeah, I just said that I don't know what date the final exam will be yet. Um, but once they tell me, I'll tell you. Although it shouldn't matter too much exactly the date because you guys will have a couple days to work on it and send it in on your own time. So don't worry too much. Is there any questions about anything from the semester before we get started? So just to remind you guys, um, thank you all for submitting your referee report. So far, all we have left now is your assignment 3, which is a coding assignment based on chapter 5, and then the final exam, which is open book, and it will be a couple of days. Jorge, how can we prepare for the exam? Honestly, like go through the slides. That's what most of my questions are going to be based on. Also, like if you've done the assignments, it's prepared you well for the final exam because they're kind of like questions about thinking empirically, about different sources of selection bias and interpreting estimates, um, pretty standard stuff like that. I will focus a lot on the assumptions. Yeah, assumptions of the model. Um, I think just like reading the slides, and if you need to go back to the old videos, they're going to be on Google Drive. And then also tonight I'm going to ask um, Teresa from the department if she can upload the rest onto YouTube. So you guys, if you need subtitles, they will be there. How will the final exam be? Um, it's going to be mainly long answer, I think. So it will be a question you might have to um, solve some problems, but not too mathematical, like maybe solving for the Wald equation or interpreting estimates, figuring out whether they're statistically significant. Um, but most of the questions will basically be based on maybe some research and what you guys think of them, whether methodologies are appropriate. So it's going to be long answer kind of questions, very open. Um, there might also be multiple choice, like maybe 10 questions of multiple choice. And when is the final exam? I don't know because the department hasn't given us the date. Um, I just, for me, like it can be whenever because you guys will have a couple of days to work on it. But I just want to make sure that you don't have like every exam at the same time. So I want to be considerate for you guys for any other exams you might have. So I'll try and figure out by Friday when your final exam is. But you will have about 2 days to work on it. So um, in the final exam, do we have to run some commands in Stata? No, so it's not going to be any coding for the final exam. It's all going to be written. So I never thought about how it will be submitted, but I suppose that I will post the final exam in SIGA, and so you can download the exam and then answer it in like a Word document or something. Or even if you need to write it out on paper and like scan it or take a picture or something, if it's a formula, you can do that. So, and then just send me an email. So it'll be the same as the assignment process. Just make sure that when you submit your final exam, your name is on there, and that should be good. Obviously, the final exam is individual. Okay, so I'm making the questions more open, like long answer questions. to discourage cheating. So if it's a very simple, like answer this question, like mathematically, it's a lot easier for you guys to cheat. So I'm gonna leave them more of like a long answer response so you can think about it on your own, just based on what we've been covering in class, like randomization, difference in differences. It could be a question on synthetic design or regression discontinuity, or it could even be something from the first semester about, or sorry, not first semester, the first chapter about like external validity, internal validity, or what's like the difference between a retrospective or prospective design. Can we use the translate to our final exam? Yeah, like I don't, you can use dictionary, whatever. I mean, it's open book, so I guess you'll have Google. Like I'm not going to be able to see that. So yeah, that's how it's going to go down. Any more questions that I haven't answered? Okay, so actually, I haven't made the final exam. Oh yes, Sonia? Oh, okay, no. So I haven't made the final exam yet, but I think it's going to be a written component, a multiple choice, and a true or false and explain. I'll write that in here. Will there be specific questions about the papers? Maybe. There might be, because I mean, you guys can go back into the slides. It's going to be open book, so you can check your resources. So I think this time, like last semester, I didn't test on papers, but this time it might be more fair to go back and make you read through a paper and make sure you understand it well. So yeah, that's definitely possible that it could be on a paper that we've covered. Anything else? Okay, so just make sure that you don't forget about your last assignment, 3. It's due on June 14th, so in 4 days. So make sure that you submit that. Same thing as before, it can be in groups of 2 and just submit 1 per group. And make sure your name's on the document name and like the actual PDF. And then yeah, I'll let you know as soon as I find out about the final exam date. What else? Okay, I guess we'll finish then. Was there any questions about any of the content for the other chapters that you want to go over again? The one good thing about this semester is that you guys have all the recordings of my lectures. So if you feel like you're going through the slides and you're confused on anything, you are able to go back and see what we were talking about. Okay, sounds good. So we'll finish off chapter 6 and be done with this class then. Okay. Okay, so for those of you who were here on Monday, we were talking about this paper called The Effect of Alcohol Consumption on Mortality. It's a regression discontinuity design on the minimum drinking wage in the United States. Okay, so basically what the authors are doing here is they're looking at the discontinuous change in drinking behavior from when a person turns 21 years old. And they're looking at that effect of the increase in drinking behavior on mortality rates from motor vehicle accidents. Okay, so the reason why they couldn't just run an OLS regression of how much an individual drinks on car crash data or mortality rate data is because the problem is that there's some omitted variable bias. And what we found on Monday was that this omitted variable is whether an individual is risk taking, right? So it's actually this self selection problem where maybe someone who doesn't care as much about their future or they're more risk taking, they'll drink more alcohol and they'll also decide to drive worse or more riskier. So it's not actually that the drinking is causing this car crash, it's that just someone is more risky in both drinking and driving. So we want to avoid that. So the authors decide to use a regression discontinuity design, looking at the sharp change in your ability to drink alcohol after you turn 21. So based on what I've told you, do you guys think that they use a sharp RD or a fuzzy RD?
It will be better fuzzy because of imperfect compliance.
What do you mean imperfect compliance?
I mean, because of you don't know if like. Oh no, sorry, I'm confusing a little bit.
No, you're right. You're right.
Yes,
Yeah.
I thought because like they would drink alcohol before 21, right?
Yeah,
So
exactly. And like also some people, even when they turn 20, they choose not to drink alcohol. So for sharp RD to work, you need that perfect compliance on one side or on both sides, I guess, right? So you want it to go sharply from 0 to 1. No one's drinking when they're below 21, and everyone's drinking after they're 21. And we know that that's not really reality. Some people drink before they turn 21. Some people just never drink. So we have the case of always takers and never takers. So that's why they do use the fuzzy RD here. So yeah, they're combining two data sets. One is on obviously alcohol consumption, and they have data on their birthday from that. So you need to know exactly when the individual is turning 21, so you can measure changes in their drinking behavior. And then they also have data on mortality rates. So they look at mortality in terms of, sorry, oh yeah, so they look at mortality in terms of external causes and internal causes, and they're mainly interested in external causes here, which would be motor vehicle accidents. But yeah, within external causes, they break up into subcategories as homicides, suicides, the motor vehicle accidents, and then death with a mention of alcohol or with a drug use, and then any other. Okay. So then they're using both a parametric and non-parametric estimation strategy. So this one you can see they're parameterizing the relationship between drinking alcohol and the mortality rate, which is the y. And so they're using this function gy of a to basically, it could be a low order polynomial, they say, and that's going to measure the baseline relationship between drinking alcohol and these motor vehicle accidents, which we know there might be some selection bias because maybe more risky people are more likely to do both. So we don't really care about this estimate, but we just acknowledge that it's there. Whereas we care about this and D as the causal effect of interest, right? So this is the dummy variable if you're over 21. So we want to know about the sharp discontinuity effect, not really the gradual or whatever relationship between drinking and car crashes. Okay. I'm kind of going fast through this because we covered most of this yesterday on Monday, so it's just for people who maybe weren't here so you're not too confused. Okay, so yeah, so the authors, remember that this is a fuzzy RD, so we need to look at both the first stage and the reduced form. So the authors are reporting both the change in alcohol consumption and the change in mortality, right? Because when you turn 21, we don't automatically care about the effect of turning one on car crashes. We only care about that effect through the causal mechanism, which is drinking, right? So if you think of turning 21 as the instrument, we don't inherently care about the effect of Z on Y. It's always through X. That's the channel of interest. So keep that in mind. So yeah, this is just explaining why a fuzzy RD is appropriate, because the mechanism is indirect. And even though teens who become eligible to drink legally do not have to drink, and some teens may choose to drink before they meet this eligibility requirement. So there's imperfect compliance, and that means that a fuzzy RD is appropriate. So it's exactly what Nicholas said. Okay, so this is figure 1. It's just showing the age profile of drinking participants, or participation, sorry. You can see on the x-axis they have age, and they're looking between a window of 19 to 23. And age 21 is where these teenagers are legally allowed to drink alcohol. And so they're looking at the drinking behavior here. So you can see this top line is the proportion of individuals that report drinking 12 or more drinks in their life. And then below that, this dark line is the proportion of individuals who report drinking 12 or more drinks in 1 year. And then this bottom line is the proportion of individuals who report some heavy drinking in the last year. And remember, some heavy drinking is days where you drink more than 5 drinks in one moment or one night. Okay, so you can see all of these observe a significant discontinuous jump, right? So sharply at age 21, we see an increase in proportion of people who are drinking heavy and total drinks in their lifetime and total drinks in 1 year. So we do see that there is a significant first stage through this because the proportion of individuals drinking more is higher. Any questions on this first stage? This would be the classic like RD graph that you'd want to show. And then authors always want to back this up by showing the actual jump. So the difference between these 2 points and the standard error, so you can see whether it's significant. But I mean, it's clear to see here because I don't know if these are actual data points, or I think they're like confidence intervals, or like I don't know, like they're, what's it called?
I don't quite understand the data. Why it makes like this small zigzags?
Oh, it's just not a exactly linear relationship. I mean, it's kind of noisy.
No,
So,
but I mean that's the actual points or observations of the data, or is like the way the authors have put it in the graph?
I don't think it's the actual points because they have many of thousand observations, but I think they're like grouped points. So you can
Like the
say,
most representative or something like that?
no, it's like you have all this data for this area, and then they'll take an average of like the maybe like 500 observations around here, and it lands at this point.
Oh, okay, okay.
So I can't remember the technical name for it. Like they're just bundling a bunch of points together.
Like clustering or something like that?
Yeah, exactly. So it's interesting that it does look like that, because then if you actually look, it could somehow, like if you see it's going up and down here, then when you get here, you see that there's some points right here.
It's
So it
like
kind of does look like
stash-
it's just nonlinear, right? It's not, might not be discontinuous in that case.
it seems like it has like stational factor or something like that.
Yeah, so maybe they're overestimating the discontinuous jump when it's actually just nonlinear.
Yeah, or maybe in summer they drink more or something like that. Like when you but I don't think so it works that way.
During exam period, they drink more, get it straight. So yeah, this is just the graph, and then I think they look at other types of drinking. So this is frequency of drinking, and then they also look at drinking intensity. Okay, Um, okay, so this is table 1 showing, sorry, it's kind of hard to see. So this is showing the alcohol consumption, which is basically the regression results for figure 1. So you can see here they have different specifications with some include covariates. You can see the 2 specifications include covariates, different weights, quadratic terms, and cubic terms. And that's just mainly there to show that they have robustness, whether or not they do or not. So let's see. So they look at 12 or more drinks in the lifetime. And of course, over 21 is the variable we care about, right? Because that's where we would see the discontinuous change in drinking behavior. They don't include, oh, actually, these ones aren't significant. So for the 12 or more drinks in a lifetime, at the top here, oh wait, yeah, this is the top line. There's not a significant jump, right? So you kind of see like it looks like a jump in the graph, but it's not significant when you do it in a regression. And that's true for all of the specifications. And then for 12 or more drinks in 1 year, we see that, oh, so it's significant in the first regression, right? So they find an effect of like a 8% increase in the proportion of individuals who have 12 or more drinks in 1 year. And that would be significant. I can't tell if it's at the 5 or 1%, probably the 1%. They don't I hate when they don't include or stars. But that effect kind of goes down when you include for controls and robustness, right? So when they add controls and fixed effects, the effect really goes down. I mean, not really, but by a couple points. But I think it's still significantly statistically significant. And then finally, any heavy drinking in the last year, the RD effect, they find positive for, it's not robust though, right? Can you guys see how it's not robust? Because the first regression, when they have no controls and they use a quadratic term, they see a jump of about 7.6% in proportion of people that are heavy drinkers. But then they start adding controls and it goes down to 5.2%, and then all the way down to like 2.6% at the end, and it's not statistically significant. So that effect kind of dwindles, but we do see it in the first regression. So I don't know if it's overly convincing, just because of the non-linearity you see, but it does seem like there is some sort of jump. So this is figure number 2, which is now instead of looking at drinking frequency, they're looking at drinking intensity. So how many like drinks per day, or like are you drinking heavily? So yeah, they look at drinks per day here. You can see at the 21 cutoff, it seems like there's an increase in the proportion of people who have more drinks per day, or people are having more drinks per day when they're 21. But it is pretty noisy again, so I don't know if that would be significant. It would be nice if they put confidence intervals to make it more clear for everyone. And then this in the middle here shows the proportion of days drinking. So for example, out of 7 days of the week, how many days do you drink? So we see this does seem like a really noticeable jump because like unlike the other graphs, like unlike this one, you don't see similar levels and points between the control side and the treatment side. You see a clear difference in levels. So this we would assume will be significant, but we'll see in the table. So this is suggesting that when you turn 21, you're spending more proportion of days drinking. And then same for proportion of days heavy drinking. Oops. So heavy drinking is more than 5 drinks per day or per, like, I don't know, celebration or night. So it does seem like there's an increase, and it does seem a slightly less noisier in terms of data variation than the very top one. So it'd be interesting to see if this one is significant. I can't remember. Any questions on this one? Okay, so remember these are both the first stage, right? This is showing the validity or the relevance assumption that our instrument variable, which is turning 21, actually increases drinking behavior. So this is our relevance, right? So what does it say? So we see now the proportion of days drinking when you turn 21 is definitely significant, and it's pretty robust across specifications, except for this specification 4 and 5, I guess. Okay, so the first three is pretty robust, and then proportion of heavy days or days heavy drinking. I mean, look at the estimates. Let's see. It seems like here the only significant effect is in column 1, right? Because once you go to column 2, the standard error becomes almost as big as the estimate, so that wouldn't be significant. And then that stays true for the rest. And then finally, drinks per day on days drinking. So this is also a measure of drinking intensity, right? That's just not significant. So clearly we only really see the main effect through the proportion of days drinking. So when you turn 21, seems like more people spend more proportion of days of the week drinking. Oops. So I mean, although it's not the strongest evidence, they do have enough evidence to suggest that the amount of heavy drinking does increase in response to easier alcohol availability once they turn 21. So then they want to check the cutoff rule associated with the increase in alcohol consumption. We want to know if truly good is random, and that just means that basically the change in drinking is the only thing that will change across the 21 threshold. That would also affect the outcome variable, right? So this is the exclusion restriction. Remember that we want the turning 21 to only affect our outcome through our independent variable, which is drinking behavior. So this is what the authors do. So they want to check for these covariates. Okay, let's see. Yeah, so they're creating this table that checks a bunch of different covariates, and they want to basically run the same regression, so the effect of turning 21 on these covariates. And we want to make sure that there's no significant effect, because basically this is the same as a balanced table in a regression or in a randomization design, because you want the two groups on either side to be very similar, right? That's the assumption of an RD. It's as good as random when the group on either side of the cutoff are identical. So to check that they're identical, we can put a bunch of different characteristics as our outcome variable and run regression, the same RD regression as before. And if anything's significant, we can say these two groups are different, and that could affect our estimate and be biased, right? So this is what they do. See, so they're basically running the same RD regression on a bunch of different characteristics. So being male, white, Black, Hispanic, not having a high school diploma, having a high school diploma, being employed, looking for work, or no health insurance. Okay, so let's just make sure that nothing's significant because they don't put the stars. So if you guys look, none of these variables are significant. I don't know, like, does this seem complete to you, or maybe they're missing other variables that also might be important in determining whether you would get into a motor vehicle accident?
can be whether you do like extreme sports or something like that.
Yeah, to try and proxy for like how risky you are. That's a good one. Yeah, so like I don't know, like the characteristics they chose, I don't think, I mean they are kind of important, like being male is obviously important into motor vehicle accidents. We all know that guys are so risky and they always have to pay more insurance on their cars. Maybe like no health insurance could be useful if you think they don't pay health insurance, they don't think much about risks or their future. So maybe they'd be more willing to drive more riskily, but I don't know. It's kind of a loose connection to me. I definitely think they could have done more to like validate this, especially more relevant to drinking behavior and like driving recklessly. Like I don't know. Yeah, like the extreme sports could be interesting, or like do they smoke? I don't know. Anyways, okay, so figure 3, did I show you it already? Yeah. Figure 3 shows the overall age profile of deaths per 100,000 person years, and they also show the age profiles separated for deaths due to internal and external causes. So they're computing deaths per 100,000 people per year by dividing the total number of deaths at a particular age by the total number of years lived at that age by everyone in the cohort. So remember that the external causes of death include motor vehicle accident, suicide, homicide, death with a mention of alcohol use, death with a mention of drug use, and then other deaths due to external injuries. Let's see. I don't think you guys can see that, but okay. So this top line shows all deaths, so external plus internal, and then they separate the effect by external and internal. So here, the second line, or in the middle, is external death, and then the bottom line is internal death. So what does this tell you guys? What is this even showing? It's showing our reduced form, right? It's showing our reduced form because remember our outcome variable that we care about is like deaths. I mean, this is just like comparing between external and internal now, so we'll go further into motor vehicle, but we're looking at the effect of turning 21 on mortality rate. So this is reduced form because there's no mention of alcohol consumption, which is our independent variable of interest. Okay, so we see that for internal deaths, there's no change across the 21 threshold. However, there is a spike in external deaths from turning 1. Okay, so that's interesting. Let's see if there's actually a relationship between the increase in alcohol consumption now and the increase in mortality. Okay, so well, this is the reduced form regression because this is turning 21 on deaths. You can see deaths due to all causes, deaths due to external, and deaths due to internal. And like as the graph showed, the only real significant effects are within the deaths due to external factors, which is where motor vehicle accidents are contained. So that's interesting. Okay. So then figure 4 is breaking up all of the different external deaths into the different types as we talked about. So this top one is motor vehicle accidents. This is motor vehicle accidents up here. And this has the biggest jump, right? So we do see a large increase in motor vehicle accidents, which result in death at the 21 cutoff. And then you can see there's not much of a jump for, this is homicide, this is, oh God, I'm blind. suicide. This is external other, drugs, and then this is alcohol. So it's interesting, they really look at the motor vehicle accidents, and when you just look at direct drugs or direct death from alcohol causes, there's a bit of a jump. Like it does seem significant, but it's really small when you compare to the increase in death by motor vehicle accidents. Okay, and so they confirm this in a table. So they look at all the different categories. So I'm just going to go straight to motor vehicle accidents because that's the effect we care about. The others aren't significant, I don't think. Alcohol is a bit significant actually. So motor vehicle accident is significant, we can see, for all specifications. And they include different covariates, quadratic terms, cubic terms. We do see that increase in motor vehicle accidents. So their overall results are that individuals just over 21 report drinking 21% more days than individuals just under 21 years old. So that's also a similar proportion increase for heavy drinking days. So they'll also drink heavily 21% days more. They find no evidence of an increase in the average number of drinks people consumed on days of drinking, nor do they find a shift in the distribution of drinking intensity. So it's just more that the individuals are drinking proportionally more days per week, it seems like. So the authors conclude the mortality effects are not due entirely to new drinkers. Those without previous alcohol exposure. This is because there's a really small increase in the first time use of alcohol at age 21. So most people in their sample already had some exposure to drinking alcohol. And then also the mortality effects are unlikely to be driven by people's first experiences with heavy drinking. Because even though there is an increase in heavy drinking at 21, if this increase in mortality were caused by experimenting with heavy drinking, then you would expect that experimentation to end like shortly after they turn 21, and you would see the mortality rate fall like and go back to the pre-21 level, but it never goes back, right? So there's always a higher rate of motor vehicle accident deaths after they turn 21. So it's a persistent pattern. Okay, so they say that if the increase in mortality is due to the increase in the number of days on which people drink heavily, then this effect will be about 6.9 for individuals who change their drinking behavior based on the law. Okay, so remember I don't think they actually calculate the Wald estimate, right? So they gave us the tables for the effect of turning 21 on motor vehicle accidents, and they gave us the effect of turning 21 on alcohol consumption. So they gave us the reduced form and the first form. What would we do with those two estimates based on the Wald formula? The Wald formula is always the reduced form divided by the first stage regression, right? So we actually want to divide the estimate for the this effect, the effect of turning 21 on motor vehicle accidents, and divide by the change in alcohol behavior, right? Because we only care about people who are induced to drink alcohol when they turn 21. Those are the compliers. So that's the whole point of the Fuzzy-RD and the Wald estimate, which is funny because they never actually give us that estimate at the end. So they just leave it with the effect on motor vehicle accidents. Okay. So what are the assumptions for this paper to be a valid RD? What can you guys say about that? What would the relevance assumption say?
Perhaps when people turn 21, they tend to drink a lot of alcohol, and that's an assumption. Maybe that's not true for some people. I don't know.
Yeah, well, so that's the relevance assumption, is that we want it to be the case that our instrument is related to our X variable. And so our instrument is turning 21, right? And our X variable is drinking alcohol. So we need it to be the case that more people drink alcohol, or people drink more alcohol when they turn 21. Yeah, that's definitely not always true. Some people don't care much about the law and they'll drink anyways before they're legal. Some people never drink because they're not interested in it. So we do have that problem of imperfect compliance. But they do still see that positive relationship through the first stage regressions, right? So that was the first tables that we looked at. And then what about the exclusion assumption? What do we need to be satisfied there? What does the exclusion restriction mean? Come on, you guys, you know this. Our X variable is not related to, okay, yes, Susanna, that it only affects mortality through drinking. That's exactly right. So our X variable has to be completely uncorrelated to the error term, meaning that it doesn't affect anything else that could affect the outcome variable. It's only related to our Y through our X. So that's very important that we have that unique channel. Do you guys think that's satisfied here? Or could alcohol be related to something else that changes when you turn 21? Can't think of anything? Okay. Yeah, so um, it's a pretty good RD design, because turning 21 in the United States is very uniquely associated to being legal to drink. Because, for example, in Canada, like when you turn 18, you can drink, and then you can also vote, and you just get a bunch of other rights as an adult. So it could be more confounded. Whereas in the US, turning 21 is specifically unique to drinking. So that's nice. It has a very unique cutoff that allows for this experimentation. Do you guys have any concerns about the paper that you think it might be biased or you're skeptical about? No concern at all. What about the self-reporting of drinking behavior? Yeah, underreport of drinking when people are underage. Yeah, exactly. Self-reporting can always be biased. Maybe people don't want to report their true drinking behavior before they turn 21. Maybe they don't even want to report it after they're 21 if they're embarrassed. So we're always concerned about that, and that would definitely maybe make our estimate of change in drinking behavior seem larger than it actually is. Um, what about the another concern maybe would be aggregating the two data sets. So remember, they have one data set on teenagers who turn 21, and they have that data on drinking behavior. And so that's just like a small sample size. And then they combine that with basically state averages of motor vehicle accidents. Do you think those two are combinable? Like, that's fair to say that the small sample size increase in drinking behavior is reflective of a state level motor vehicle accident? It's fine. Well, I don't know. Like, to me, it's kind of concerning just because it's fine if you make kind of say that like we see an effect on the first stage and the reduced form. So we know that there's an effect of increased drinking behavior on motor vehicle accidents. But it's not as solid when you don't have that panel data, so you don't have actual individuals linked to actual motor vehicle accidents, right? And so it's hard because they're trying to say that, oh, it's like more of the proportion of people that drink like on more days of the week that affect motor vehicle accidents. Whereas when you're looking at a very specific sample size of teens that drink alcohol, maybe there's differences in drinking behavior. So it's really hard to say one type of drinking behavior results in an increase in motor vehicle accidents. I just think like it's hard to compare between levels and intensity. I just think because their data set's very specific, but that's just my opinion. So I would kind of be skeptical about their like last interpretations about what type of drinking matters. Okay, that's all I have to say about this paper. Okay, so let's cover this last paper. Do you guys want a break right now or should we just finish it? Like it's gonna take 20 minutes, so I think better just finish the paper and then you guys can hang out afterwards, right? Yeah, okay. We'll just keep going and end it early. So this paper is called Can Tracking Raise the Test Scores of High Ability Minority Students? So basically the authors here are evaluating a tracking program in a large urban district where schools with at least one gifted fourth grader create a separated gifted high achiever classroom. So when they say tracking, it's just that they're creating a separate classroom to put the high achieving students in. So that's what tracking is. So obviously there's a history of racial disparity in education within the United States. There's a really small fraction of minority students who are in the top percentile of entry tests for universities, and that's obviously a problem. So there's been significant test score gaps, which already exist since H5. And this continued on into higher years, which will widen as students progress through school. At the same time, Black students and Hispanic students are really underrepresented in advanced programs. So I don't know if you guys have improved like advanced placement or like kind of just, I mean, advanced placement is pretty logical, just a separate classroom for higher achievers. So this is asking the question, is the low fraction of these high performing minorities at the end of high school due to the failure to identify and adequately help these minority students with their high learning ability? So one approach to addressing this is having the tracking classes. So assigning students to different classes based on achievement in prior years. So they do use this a lot in the United States within schools. There's really not much of a consensus whether it's actually helpful or not. Also, another concern about this tracking program is that if you're putting the best students into one classroom, you might be concerned that students that aren't as good they don't gain from the peer effects because all of the smartest students are gone, and so that might actually make the students that are left behind do worse. And that's where most of the Black and Hispanic children are placed, so it might actually be worse for closing the education gap rather than helping it. So it's an important question.
I have a question.
Yeah.
Can that split affect the create how to say it, like psychological barriers in the students that aren't in the upper class, like
Like
saying,
they think
oh,
they're not as good.
I'm not as good as them, so like just
Yeah.
conditioning them like psychological since like earning beginning of school.
Yeah, probably. Like I would think so. So that could also have a negative impact, like it might be beneficial for the students that get put in the upper class, but it might actually harm the students more in the lower class, so it's not worth it. So it's really a matter of understanding the benefits versus the cost. So yeah, it's just unclear about the results are for this, so they're gonna do RD design. So basically they use this design in I think it's DC district, which began requiring schools to establish separate classrooms for any 4th grade or 5th grade gifted students. So anything, basically they define gifted students, I don't know, they just have to score a certain grade in a standardized test. And then, so they have to create this classroom for these gifted students, which maybe there's 1 or 2 in a classroom. Usually it's not a high percentage. But since they're creating this extra classroom, there's going to be extra seats in each class, which they can give to non-gifted students who they're still really high achieving, but they're non-gifted based on their test scores. And so they can also be put in this class. So most schools have only a handful of gifted students per grade. Then the resulting class, so they call it GHA class, so gifted or high achieving. They're basically mainly populated by non-gifted high achievers, and this will function as an upper track class for students selected based on past experience. So yeah. Oh, that's the same slide. Something's happening. Okay, so basically these class participants are drawn from the same school, and these schools in the districts are very segregated by race and socioeconomic class. The program may serve to low income and minority students who would typically be excluded from gifted and advanced academic programs. So they're evaluating the effect of this tracking program first by using the eligibility rules for the GHA class to construct the RD design. And then afterwards, they'll use a between school design to compare students in 4th grade cohorts where there were no gifted children and therefore no class to students in the other schools which had between 1 to 4 gifted students and therefore they did have the tracking program. So the first approach is the regression discontinuity design, and they're saying there's a sharp cutoff basically for students to get into this GHA classroom, and it's based on their relative position in grading. I think it's like the top 10 or something. And then the second approach is to check for spillover effects to the low ability students, right? So we're saying this might not be beneficial for the low ability students who get left behind. So they're comparing the outcomes between schools that did have this tracking program against schools that didn't. So they can see whether the low achieving students are much worse off or if they're better off or if it doesn't matter. Okay, so basically authors think that tracking would affect test scores through many channels, such as having better teacher quality, peer composition. So if you have smarter peers, maybe you'll learn more. And then also just having a better match between student ability and the level of instruction. They also hypothesized that higher ability minority students might face more obstacles in a regular classroom than white students that cause them to be underperforming relative to their potential. And that could be low teacher expectations, peer pressure that's negative, I don't know, just racism, being excluded. I don't know, like all these factors might make minority students be worse. So they show that minority students have lower achievement scores than the white students with the same cognitive ability. And the placement into the CHA class basically closes the minority underachievement gap. So it does show positive effects for the minority students who go into the tracking programs. But
Sorry,
they also, yeah.
I'm not quite sure how does the comparison is being made. I don't understand which groups are being compared.
Right. So basically, what they're comparing is within one classroom, first of all, for the regression discontinuity design, you have this, if there's a one gifted student in your grade, they'll form this classroom. So then they compare it to the students who get into the classroom. So it's like the top 10 students compared to the 10 students just below the cutoff that didn't make it in. So if there's like 100 students in a grade, they'll compare the top 10 best versus the 10 just under. Except for the gifted students, they eliminate the gifted students. So that's the within grade comparison. And then afterwards, they do a secondary comparison between students that or schools that had a gifted student compared to schools that didn't. So they're comparing between the G schools with a classroom for the tracking versus schools that didn't. I think I'll go into those specifications in a second. Okay, yeah, this is giving more details. So this is basically based on a policy that requires schools to offer the separate classroom for these 4th and 5th graders if there's at least one gifted student in the school. Basically, there's a strict IQ threshold for gifted status imposed by state law. So a typical elementary school in the district have only 5 or 6 gifted children per grade, and then even fewer of those will be in poor neighborhoods. So this is creating within school tracking program. And so these tracking programs are required to be the same size as regular classes, so 20 to 24 students. And then any open seats in the class are filled by non-gifted students at the school with the highest scores on the previous year's standardized test. So basically, once all of the gifted spots are filled in this classroom, the rest are filled by the highest achievers from the last year's standardized test. Okay, so this is just showing basically the proportion of students based on the number of gifted students in school, and the proportion of groups in a class size. So you can see that when there's not many gifted students in a school, it tends to be more populated by minority students. You can see here, minority high achievers. However, when there's a lot of gifted students in a school, it's mainly white higher achievers. So this is basically to say that there's this correlation between income and white school areas, so that there's just normally a higher proportion of gifted white students. So yeah, schools with more gifted students per cohort are typically located in richer neighborhoods and have more white students in their GHA class. Even at these schools, however, there are many high achievers in GHA classes because the schools are often set up with 2 classrooms. Okay, and so importantly, these GHA teachers are drawn from regular staff or regular teachers. So there shouldn't be any better teacher effects confounded in the estimates. They only want to know the difference of having the classroom not that they have the classroom plus a better teacher, right? So these are normal teachers, and these teachers must complete a set of 5 courses on gifted education. They don't receive any extra salary, so there's no incentive to do better. And the students have to do the same curriculum as everyone else in regular classrooms, but normally they go through it faster so that they have extra time to spend on new topics. But yeah, they have the exact same textbooks, they cover the same material, it's just that they typically cover more material at a faster pace. Okay, so basically they think the causal mechanism is that, well, really what you want is that the match between students and the level of instruction is better. So the more high ability students are learning at a higher rate, and then also it could be teacher quality, so that more effective teachers are assigned to the GHA class, they'll be made better off. But I don't know if you want to capture that in the effect, to be honest. And then the third channel is through peer effects. So basically the peer effects is the idea of when you're in a classroom of smarter people, you'll learn more, which is the peer effect. The only problem is that if the peer effect is true, then there could be negative peer effects for students that get left behind in the lower ability class. But the authors don't think this will be too large. I don't know why. They think because there's only a small fraction of students moving to the GHA class. Also, they think it might be beneficial for minority students if there's some sort of distraction or obstacle holding them back in regular class that they can ignore in this tracking class. Okay, so as we said, they're using a regression discontinuity design, which, did I say what it is? Okay, I didn't actually specify their regression. So their regression is for the continuity design. They have a cutoff point of a standardized grade from the last year of the kids testing. So they say, okay, well, we'll let 20 kids into this class. So the 20th highest grade will be the cutoff, and anyone just below that will be in the comparison group. To be honest, I don't know if this is the best research design, because you can think of reasons why the top students would be better or perform better in the GTA class than the slightly lower scoring students. So I don't know if this is fully convincing, but that's what they do. And then they also compare the between school sample to make sure that the lower ability students aren't being hurt by this program. Okay, so this is just the balance table. They look at all the students in 3rd grade between 2008 to 2011, and then they break it off between the RD sample, so plus or minus 10 from the cutoff, and then they compare all students or all schools and then cohorts with a lot of gifted, and then cohorts with only 1 to 4 gifted. And so you can see here that cohorts with 5+ gifted, they have a lot more white students and more Hispanic too, and more Asian. Like they're quite different. You can see that the income's even higher. So there are differences in the number of gifted students, but we saw that in figure 1 too. So they'll only compare within those categories. And then for between school cohorts, you can see it's not super balanced either. There's differences, and there's higher, I mean, more white people are within the high ranking in schools than in the low ranking. Also, another thing is like the mean test scores are way off, right? So for this RD sample, you can see that the one group has really high reading scores and higher math scores, to be honest. So yeah, I don't know if it's super balanced. That's why I just don't think it's the most well done regression discontinuity. But that's why you need to see some perfect ones and some not so well done ones so you can understand where to critique. This balance table is just showing that the groups aren't super comparable, but I guess they aren't comparing these two, so it's fine. So anyways, their RD sample, they're identifying fourth graders who had test scores from the third grade and who were in the schools or cohorts with the fourth grade GHA class. So basically how to determine who is going into the class is determined by a formula, which is a combination of their reading score and their math score from the last year's test. And so from there, they can calculate the cutoff score for admission into the GHA class. So it does change every year, and it depends on how everyone performs in their last year's test. So it's really hard to manipulate this one. That's the good quality about this RD design, because you don't know exactly what grade you need to get into the GHA class, because it's all standardized and it depends how everyone performs last year. I just don't know if the two groups actually look the same. So yeah, for the between school analysis then, they focus on students from the schools with 0 to 4 fourth grade gifted students, and they use the formula to construct their within school rankings, so basically rankings of ability or academic performance. So they rank students from 1 to 20, and they find that these students are more likely to move to a GHA class if one is offered, while those ranked from 25 to 44 are more likely to stay in regular class regardless of ability. Okay, so these are the results. You can see this is the RD design, right? So ranking from the cutoff, so they just standardized to 0. There doesn't seem to be much of effect on reading or math, but there might be a small effect on nonverbal ability. It just doesn't seem that like there's a huge statistical jump, right? So let's see their regression discontinuity table results. So this is baseline, so you don't expect any effect to be there. First stage, so remember this would also be a fuzzy RD, sorry. The reason it would be a fuzzy RD is because they don't, what is it? So based on an individual's ability in the previous year, they want to know the probability that they'll enter this tracking classroom. And they want to know the effect from there on how they'll perform in the final exams, right? So it's kind of a fuzzy RD in that sense, because it's not that there's kind of an imperfect change in what the probability of entering this GHA classroom. It's not a perfect system. Maybe for some reason some schools don't comply completely, so maybe they think some student really deserves to be in this classroom and they'll put them in regardless of their grade. Maybe some students choose not to join the classroom, so for that reason it's imperfect and they choose to do the fuzzy. Okay, so we do see positive effects actually on reading and writing grades from joining the classroom, right? So you can see that students are more likely to have higher grades in the GHA classroom than compared to the comparison group. That's even including for fixed effects on the school and year level. And then they even difference it. So difference is just the difference between an individual IES test score in grade 4 to grade 3. So you see positive effects there as well. Okay, so this is the first stage relationship for being placed into the GHA classroom. So this is exactly what I was saying before, is that it's not perfect compliance. There is some probability of entering the GHA classroom, even if you don't meet the cutoff requirement. And even then, not everyone who is eligible for the classroom will take it up. Maybe some people just prefer to be in the regular classroom. And so for that reason, there's imperfect compliance and they use a fuzzy. So they're showing a 25% placement rate just to the left of the threshold and 60% to the right. So we do see that positive increase in probability, which is needed. And then these are the actual final results graphically. So you can see that there is a jump in reading and math at the cutoff. So there's an increase in reading scores just from entering the GHA, and same for math, but writing isn't significant. And then panel D and E are just the difference results that we talked about earlier. Okay, then they do a heterogeneity test. So this is really looking at the, this is just showing the results from the graphs. So we should expect them to be significant since we visually saw them. And you can see that for the full sample, the effects are significant, right? So there is a positive increase in reading and math scores. However, when you look at the heterogeneity effects by race, there's really no effect for white students, but there's a very large effect for the Black and Hispanic students, and even larger for just the Black students. So the positive effects are really concentrated in these Black students, which is interesting. So they're really better off being in this GHA classroom than in the normal classroom. Okay, so their one concern with the RD estimates is that the result might be driven by the impact of GHA classrooms on non-participants. Like it could be the case that this program, not only is it making the students that go to the classroom better off, but it's also making the people that don't go to the class worse off. And so it's actually affecting the control group, and that would be a spillover effect, which creates bias, right? So we always want our control to be unaffected by treatment. So they are concerned about that happening with reason. So then they're going to compare fourth graders ranked just below the top 20. And so they want to see the effect of these on these students, because basically if you see a decrease in test score performance, we will know that there's a spillover effect, probably due to the peer effect, right? So they're identifying the top 20 students and then the students below them, so 25 to 44, based on previous year's academic scores. And what do they find? So this is have the effect of having one or more gifted student in a fourth grade school. So that just means you have the GHA classroom existing in your grade. So, okay, so this is the effects. Average third grade reading and math. This is for the students ranked 1 to 20, so they're in the GHA classroom. You see a third grade. Okay, so third grade isn't when they go into the classroom. We're considering fourth grade, so we don't expect an effect to be there. So we do see an increase in probability they'll be in the fourth grade class, GHA classroom. And then from there, we see positive effects on reading and math skills. So that's what we expect to see, because these are the students that are going into the tracking class. But what is the effect for the students ranked 25 to 44? Well, we see one effect. I think they're all insignificant. There's really no effect except for the second one, which actually showing a positive effect. So it doesn't seem like they're actually made worse off. If anything, they're not affected at all and maybe better off. And the reason that they could be better off is because when you're taking half of the class and putting them in their own separate classroom of high ability, then maybe the students in the lower program, they have more individual attention, they have a smaller class size, so they might actually be better off too. But there's really not evidence in this showing that they're harmed. So that's good. So it does really provide promising evidence that this tracking can be a beneficial program, as it doesn't appear that there's too much of a negative spillover effect on the lower ability students. I think this paper, you guys will probably agree with me, is less convincing of a regression discontinuity design than the mortality alcohol drinking when you turn 21. Just because like there's a lot of reasons that there would be differences between people who can just get into the GHA classroom compared to people who just can't, right? And that's based on test scores, ability. So I think it's a lot different from that using age as a cutoff, because when you can say, okay, someone who's 21 in 1 month probably isn't that different from when they were 20 and 8 months. So those are a lot more comparable than saying, okay, well, someone who scored 99% compared to someone who scored like 90%. Maybe they're similar, but there might be characteristics that are different. And they really don't test this at all, right? Remember how in the first paper they showed all of the characteristics running smoothly across the cutoff? They don't do that in this paper, which makes me suspicious that maybe they don't run smoothly. Maybe there is some difference between the two groups. Any questions on that? Okay, well, that's all the papers. So if you guys have any questions at all about the final exam, you can email me. We can also have meetings, that's fine. Just be aware that all of the recordings of my lectures are in the Google Drive, it's in SIGA, and that your assignment 3 is due on June 14th. But you can finish earlier if you want, that's fine with me. Okay, so if there's no questions, I hope you guys have a great the rest of your semester. Good luck with your final exams. It's been great teaching you guys. I hope you learned something. I know it must have been challenging to do all of this online. It's been a crazy few months. Just hang in there. I'm sure you guys will all have good careers. Good luck in the future. You can always reach out to me if you're ever in Canada or the US. Okay, thanks. Bye. Thank you guys. It's been fun.